Welcome to 5-Minute BTech channel. Today we're jumping right into axis angle rotation. This is the core concept, really the secret sauce that makes movement in virtual reality feel so incredibly real and intuitive.
So here's what we're going to break down. First, we'll talk about why rotation is just everything in VR. Then we'll get into what axis angle actually is, why it's the go-to choice for VR systems, and see a couple of real-world examples. And finally, we'll connect it to this other big idea called Quaternions.
All right, first things first. Why this huge focus on rotation? Well, it's pretty simple. In the 3D space of VR, almost every single thing you do, from looking around to grabbing an object, boils down to a rotation.
I mean, really think about it. The way your headset knows where you're looking, that's rotation. The way you twist your controller to aim or interact, that's rotation too. Even stuff you might not think about, like which way an enemy is facing or how a menu is angled towards you, it's all powered by rotation calculations, happening constantly in the background.
So this brings us to a really elegant and honestly super intuitive way to describe all this spinning around, the axis angle method. The beauty of it is that it works almost exactly how our brains naturally think about movement.
At its heart, any rotation you can possibly imagine in 3D can be boiled down to just two simple parts: an axis, which is just an imaginary line that you're spinning around, and an angle, which is, how much you spin.
Let's look at those two pieces. The axis gives you the direction. Think of it like a skewer through an olive. Are you spinning it top to bottom, side to side, or at some weird diagonal? That's your axis. Then, the angle gives you the amount of rotation. Is it a small 45-degree turn or a big 180-degree flip? You put those two together and bam, you can define any rotation perfectly.
So that leads to a really important question, right? Why is this specific method so darn important for VR hardware and developers?
And it's a fair question. There are definitely other ways to handle rotation out there, like Euler angles. But axis angle has a couple of massive advantages that basically make it the undisputed champ for virtual reality.
The first big win is that it literally speaks the same language as the hardware. The tiny little sensors inside your headset and controllers, the gyroscopes, they naturally detect movement as a rotation around a certain direction by a certain amount. That maps one-to-one with the axis angle model. It's just clean, direct, and super efficient.
Now, the second advantage is arguably the most critical one. It completely avoids a nasty problem called gimbal lock. This is a weird glitch that can happen with other methods where your movement can get stuck or suddenly flip out when you're looking straight up or down. It feels terrible. Axis angle is immune to this, which guarantees the smooth, stable tracking you need for VR to feel good.
Okay, that's enough of the technical stuff. Let's see what this actually looks like in practice, with moves you're making every single time you're in VR.
Let's start with the absolute most common thing you do in VR, just looking around. When you turn your head to the left, you're basically rotating around a vertical line that runs right through your body, right? Well, that's your axis, the y-axis. And the amount you turned, let's say 30 degrees, that's your angle. It's really that simple, an axis plus an angle.
All right, now let's try a move that's a little more complex.
Okay, so picture twisting your controller, kind of like turning a key in a lock. The axis you're rotating around isn't a simple up, down, or side-to-side line anymore. It's the line pointing straight forward, out from the controller itself. And the angle is just how much you twisted your wrist. This ability to use any direction as an axis is what makes the system so incredibly flexible.
So, we've established that axis angle is fantastic for us and for the sensors. But what happens once that information gets inside the game engine, like Unity or Unreal? Well, that's where a new player enters the game.
Let's follow the data trail for a second. First, the sensor in your headset detects you moved. The system sees that movement and says, okay, that's an axis angle value. But to do all the really heavy lifting and complex math that draw the 3D world, engines prefer to use something called a quaternion. So the engine takes that simple, intuitive axis angle data and quickly converts it into this super efficient format. That is what it uses to rotate the entire world around you.
So, to bring it all home, axis angle is the most natural way for us and for our hardware to think about rotation. The VR engine then acts like a super fast translator, converting that simple language into the powerful mathematical language of Quaternions. And that conversion is what ultimately gives us the seamless, realistic motion that makes virtual reality so absolutely amazing. If you like the video, hit like and subscribe to the channel, and I'll meet you in the next video.